Good day, everyone, and once again we're back together. All right, so we'll be looking at Boyle's law today, some guest laws. So if you have not subscribed, please just make sure you're part of the family. All right, so let's get right into it. Right, so they say to us that we've got a certain amount of gas that is sealed in a container of which the volume can change, right? They say the relationship between the pressure and volume of the gas at 20 degrees Celsius is investigated, right? They say the results of this experiment are given in the table below. All right, now let's have a look at it. They've given us the results of the pressure, right? It's given in kilopascals as well as the volume in cubic decimeters. Right, now they say to us, name the gas law that is represented, okay, by this experiment, by the results of this experiment. Now you would remember anytime we are experiencing, or rather experimenting with the pressure and volume, we are simply talking about Boyle's law, right? So definitely that's going to be Boyle's law. Right, now they say to us, write down the hypothesis rather, of this investigation. Now remember, what is the hypothesis? It is a statement that you make that is predicting the relationship between the independent and the dependent variable in this case, right? So how do the pressure and the volume relate with each other, right? And by the way, your hypothesis can be proven to be either true or false. But if you are making a hypothesis, you cannot get wrong, for a presumption that you make. Okay, right. So it's a calculated guess, basically. Right. So what can we say? If you notice there, I can see that as I increase the pressure, the volume of the gas decreases. Okay, so that's what I'm simply going to say, right? That as the pressure, okay, of the fixed mass of gas of the fixed mass of gas increases, okay, the volume decreases. The volume will decrease. Okay, right. And so that would be my guess, right? That obviously as I increase the pressure, the volume would decrease. Now on the next question, they say to you, draw a graph of volume versus pressure, right, on the answer sheet that is attached. So I went and obviously got myself that answer sheet in this case. So there we are. Volume is on the dependent, on the y-axis, right? So the dependent axis, and pressure, which is on the independent. Now, for us to draw the graph correctly, we first need to see, of course, the lowest and the highest value, right? And then be able to choose a scale, obviously, with what we are given. Now, what I'm going to do is just count there. How many, lines do we have, or how many divisions do we have, right? So if I look at it, so we've got 1, 2, 3, 4, 5, 6, 7, and 8, right? That is on the Y. And in this case, for my pressure, I've got a range from 70 to 260, right? So what would be a scale that I can choose there, right? And by the way, when you choose any scale, that's really up to you, but it must at least, cover more than half of the of your graph, right? So let's see. If I say 260 divide by 8, okay, I get 32.5. So perhaps a scale of 40 there would work, okay? But I can also choose 50, right? So it would be easier to work with 50s than 40s. So that's 50, 100, that's 150, that's 200, that's definitely 250, and 300 over there. All right, so that is my pressure. And then we're going to look at volume. So the highest value that I have is 174, right? Having started from 47. Okay, so again, I can do the same thing where I can check what would be a suitable scale there, right? Let's say the highest value. Remember, we've got 8 lines, 8 divisions there. So I can say, well, 174, or let's just say 180, right? Divided by 8, and you get, well, 22.5. So anything that is above 22.5 would be able to fit that in. So I'm going to choose 25 as my scale. So 25, that's 50. Okay, that is 75, and that's 100. Okay, and that is 125. That's 150. And this is 175. Okay, all right, I'm going to leave it there. Okay, if you want to, we can write down 200 over there. All right, now let's try and draw, our graph as quickly as we possibly can. All right, so I think my graph shifted a bit. Okay, let's see. All right, okay. All right, it seems like it's still okay. Right, so let's see. So the first point that I have is at 70 and 174, right? So we've got 70 and 174. Now I want you to note, so my scale on the x-axis is 50, right? Which means, now if you note there, it means per line I'm increasing by 5, right? Okay, so what you do, you'll just simply say 50 divided by 10. Remember, there are 10 lines in between two of your major lines or major divisions in this case. So 50 divided by 10, that would give us 5, right? So now we are looking at 70 rather. So that would mean, okay, so that would be 50, that's 60, that's 70 somewhere there. That's our 70. And when the pressure is 70, right, the volume is 174. Okay, so there we are. We had 50, we had 60 there, we had 70, and 174. All right, so I'm just going to put it just a little bit below there. All right, so that's our... Right, that's our point. Okay, and then the next one, I've got 95 and 128. All right, let's try and be a little bit faster. So that's 95, okay, and 128. So remember, if this is 100 over here, right, so 95 would just be one line below, right? So let's go there and find 128. So this is 125 over there. Okay, and again, I want you to note, so that's 25, so which means we are increasing by 2.5 for every line, right? So that would be 125, that would be, right, that's 126 over there. Okay, so we said, all right, so in this case, sorry, that would be 130 rather, and we are looking for 128, right? So which means that I am going to look at somewhere there. So we said 95. Okay, so that's 100, so that's 95 over there, and 128. Okay, so I'm gonna put it somewhere there. Okay, right, so that's 95 and 128, so that's below 130. All right, okay, and just a little bit above that line. Okay, so we've got 130 and 93.6. okay, so there we are. We said we are increasing in this case, so that's 110, 120, and 130. Okay, right, so that's our 130 line there. Okay, and we said and 93.6. Right, so that's 100. Okay, so we have to try and be as precise as possible. So 93. Okay, so we know that just slightly below, that would be, right, so we said we are incrementing rather by 5. So that would be 95 there. Okay, and it would be somewhere there, as well as in this case 130, right? So 130, so that's 110, 120, and 130. Okay, so we're looking at somewhere here, right? Okay, I'm just going to put it somewhere there. Oh, you're getting the hang of this, right? Okay, all right, let me just put it there. That's where my 130 is. Okay, and we've got 165 and 74. Okay, so 165 and 74. Right, and ladies and gents, this can be really cumbersome to draw, so really try and be as accurate as possible when you are in the exam, right? Okay, so we are looking at 165. Okay, so we've got 150 over there, we've got 160 and 165, right? That's that point over there, right? And it's sometimes could be even easier if you just use a line. Okay, so there's my 165 over there. All right, so you could use this line, we can remove it later. Okay, and now we're going to look at, so that's our 165 line, and we are looking at 74, right? So that would be obviously just slightly below 75. Okay, so that's 75 over there. All right, and 2.5. Okay, so we're just going to be slightly below here. Okay, so that's below 72, 75 rather, just slightly over there. Right, so there's our ruler. Okay, so I'm just going to erase that line so that it doesn't disturb us. Okay, and I've got 205 and 59. Okay, so again, this is 200 over there, right? And 205 is just next to 200. Okay, so it's this line over here. Okay, right, so there's 205. It's that line over there, right? Okay. So there's our 205 line. I just missed it by just a tiny degree. So there's our 205 line. Okay, and in this case corresponds to 59, right? And where is 59? Okay, so we've got 50 there, and we've got 55, and we've got 60, so that would be just slightly under 55. So there's our point over there. Okay, right, we're coming with it quite nicely. So that's 40, 240 and 51, right? Okay, so they're becoming a little bit easier. So there is 250 over there. So 240, okay, just slightly below that. Okay, so there's our 240 line. Again, so I'm just going to get rid of all of these lines afterwards. So there we go, we've got 240 there. All right, it's not fully 90 degrees. All right, and We said 240 goes with which? 240 and 51. Okay, so I'm just going to put it slightly, just slightly above 50. Okay, just some tiny bit above 50, right? Actually, I drew 240 in the wrong. It's actually the one next to it. So it's actually here. All right, so I'm just going to remove it there. Remove this line, remove that line as well. All right, and we're almost there. And the last one, we at 260 and 47. Okay, so 260, right? There it is over there. So we've got 260, okay, and 47. Okay, so we know that we would be at 47.5 there. Okay, and there's our 260 line, so it's almost somewhere there. Okay, right, so okay, so let's remove that ruler so that we can be able to draw our graph. And when you look at the pattern on that graph, it does actually concur with a pressure versus volume graph. Okay, right, so all we are simply going to do, ladies and gents, is that we're going to try and just try and connect the dots together, right, as much as you possibly can. Of course, I've got butterfingers today. Okay, so let's try it again. Okay, but you get the point, right? Okay, there we go. That is our graph. Of course, the first portion, you can fix that for yourself there. All right, so ladies and gents, that is how you would draw that graph. Right, let's answer the questions that follow. They say calculate the volume of the gas at 300 kilopascals, right? Now, this is what is called extrapolation. This is when you are now using the data that you have, right, within its limitation, and you are now predicting a value that is outside of the data that you have, right? So in this case, they want us to calculate the volume. So remember, I'm going to take any value that I have there. So using Boyle's law, so we know that P1 V1 is equal to P2 V2. And please remember, when you're using pressure and volume, right, that they must be in the same units, right? So let's take pressure 1. Okay, let's take actually the last values that we have, 260 and 47, right? So that's 260 and the volume was 47. But now I want the volume when the pressure is 300. What would be the new volume? And of course, all we're simply going to do is divide by 300. Okay, so that cancels with that. And what would be our new volume? All right, so let's calculate there. That's 260 multiplied by 47, and that's divided by 300. Okay, right, so look at that value. You get 40.73, right? And remember, the previous volume was in cubic decimeters, so that means you're also going to calculate it in cubic decimeters, right? And you can also check. You would get approximately the same value if you had used a different point. Say, for instance, if you decided to use the point 70 and 174, right, you would be able to get the same point. Okay, right, in fact, we can just try it out. So if we take 70, and in this case, we had 174, right? Yeah, our volume was 174. And we know that we're looking for the volume when the pressure is 300, okay, because I'm thinking of 300. And you can divide by 300 there, okay, and you can check that volume. It wouldn't exactly be the same, right? But approximately it would be more or less the same value. So 70 times 174, and that's divided by 300. Okay. And what do we get? We get 40.6 cubic decimeters. You see that the value is more or less the same, right? So in this case, it does tell us that we are on the right track. Right, so they say when the volume of gas is measured at 300 kilopascals, it is 44 cubic decimeters. Explain why the measured volume differs from the volume calculated in 4.4. Right. Now, ladies and gents, I want you to always keep in mind, when we are dealing with gas laws, right, we always assume that we are dealing with ideal gases, right? But what happens with real gases at high pressure? Okay, so at high pressure, of course, those intermolecular forces start to become real, right? So they said to us, explain why the measured volume differs from the volume that is calculated. Okay, so we can simply explain that real gases, okay, deviate from ideal gas behavior. From ideal gas behavior, okay, at high pressures, at high pressures, right? At high pressure. Okay. Alternatively, you can say that right, this the calculation that was made is it is assumed that we are dealing with an ideal gas, whereas the measured gas rather is a real gas, right? Of course, there should always be a difference there. Right, in this case 4.6, they say which temperature conditions will cause a gas to deviate from ideal behavior, right? Right, only high or low. Of course, if you watch my video on ideal gases, I did explain that at low temperature, right, what happens? Right, the intermolecular forces become, even more, they increase rather, and as a result, the gas would liquefy, right? So it would definitely be at low pressure. Low temperature. So 4.6, our answer would definitely be low. And at 4.7, they wanted us to explain the answer in 4.6, right? And what would be our answer? We know that at low temperature, okay, real gases experience intermolecular forces, right? Intermolecular forces, and therefore liquefy. Okay, right. And by the way, ladies and gents, we can express this, in any way, as long as you touch on, the main points, right? Or what you could say is that at low temperatures, right, the intermolecular forces begin to take effect on a real gas, and as a result, it tends to liquefy, or you can say it condenses, okay, or the molecule condense, right? So we can talk about the condensation of molecules. All right. Right, so in any of those ways you can express it, right? So the last one, they say calculate the number of moles of the gas in the container at the initial pressure and volume. Now, at the initial pressure and volume, we had 70 and 174. They want us to calculate the number of moles. Of course, we are going to use our ideal gas equation. PV is equal to nRT, right? So remember that when pressure is in kilopascals, volume has to be in cubic decimeters. And if pressure is in pascals, then you use cubic centimeters. But of course, in this particular case, they are given in kilopascals. So we're going to have, we said our pressure is 70 rather, and volume's 174. So that's 70 times 174, right? We want the number of moles. Remember R, the ideal, the universal gas constant, that's 8.31, multiplied by the temperature. Now, please remember, temperature must always be in Kelvin, right? So what we're going to do is take the degree Celsius scale, which was given as 20 degrees. You remember? There it is at the top there, right? And we simply add 273, right? Okay, so let's find out what our number of moles are. Of course, we're going to divide by 8.31 times 293 when we add those up, okay? Of course, what we do on the left, we do on the right, so that's divided by 8.31 times 293. Right, so that cancels with that. And what do we get for our number of moles? So we're going to have 70 times 174, okay, and we divide that by 8.31 divide by 293, okay, and we get 5 moles in that case. Right, so the number of moles in this case would just simply be 5. All right, and ladies and gents, I hope that you understood that. Okay, I'm going to leave it here, right? Boyle's Law is quite a nice section, and you can get yourself some good marks. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.